The story of 3I/Atlas truly began on July 1, 2025, in the clear, cold skies above Chile. At the summit of a remote mountain, the Atlas Survey telescope swept its gaze across the heavens. This telescope, part of NASA's Asteroid Terrestrial Impact Last Alert System, was designed not just for discovery, but for vigilance. Its mission is to scan the sky multiple times each night, identifying moving objects that could threaten Earth, or, as in this case, expand our knowledge of the cosmos. On that night, the telescope captured a faint point of light moving just differently enough to raise suspicion. Within hours, astronomers were checking and rechecking the data. The object's speed and path didn't match anything catalogued in our solar system. And by the following day, July 2nd, the Minor Planet Center had already confirmed what many suspected: this was no ordinary rock. Its orbit was hyperbolic, meaning it was not bound to the Sun at all. It was an interstellar visitor. Only the third ever identified in human history. That confirmation in less than 24 hours marked a leap forward in scientific readiness. In 2017, when Oumuamua first appeared, it took weeks before its interstellar nature was fully recognized. By 2019, with Borisov, the turnaround was faster but still not immediate. Now, in 2025, the systems of detection, collaboration, and verification had matured so much that humanity could recognize an interstellar traveler in a single day. It was proof that astronomy itself is entering a new era, one where interstellar objects may soon be found every year rather than once a decade. 3I/Atlas's trajectory left no doubt. Its immense speed, more than 210,000 kilometers per hour, or 130,000 miles per hour, was far beyond what our sun's gravity could capture. Like a skipping stone, it would swing through the solar system once, and then sail back into the dark, never to return. That knowledge gave the discovery a bittersweet quality. A rare opportunity paired with an unforgiving deadline. And so, as the public traded memes and theories, scientists set their focus. This was not a story about aliens or doomsday. This was about gathering every possible shred of data during the short months that 3I/Atlas would remain visible. Telescopes across the world were pointed at the skies. Data streamed from Chile, Hawaii, and beyond. And in the background, a sense of urgency grew. If this object truly was a messenger from another star system, then every night counted. In late June of 2025, the news cycle suddenly exploded with headlines that seemed ripped straight from a science fiction movie. Manhattan-sized object detected in space. Alien ship enters the solar system. These words flashed across television tickers, news apps, YouTube thumbnails, and podcasts. They were repeated so often, and with such urgency, that they created a sense of immediate danger, as if the world had only days to prepare for some incoming threat. Across social media, the story mutated. Some posts warned of a possible doomsday impact. Others declared, half seriously and half in jest, that aliens had finally arrived. Memes, reaction videos, and live-stream debates appeared within hours. People who had never paid attention to astronomy before were suddenly glued to their screens, searching for answers. That first descriptor, Manhattan-sized, was especially powerful. Even if it was only a rough early guess, it created an image so clear that people could instantly picture it: a giant block of rock or a colossal ship, larger than an entire city, drifting silently above us. Once an idea that vivid takes root, it spreads faster than the facts. This isn't the first time such a thing has happened. Back in 2017, when the first interstellar visitor, 1I/Oumuamua, was discovered, the strange elongated shape and tumbling motion sparked speculation that it might be an alien probe. 2 years later, in 2019, 2I/Borisov was spotted, looking far more like a typical comet. And now, with 3I/Atlas, the cycle began again: headlines, speculation, debate, and only then, the careful voice of science. But behind all that noise lies the true significance. 3I/Atlas is not just another asteroid or comet from our solar system. It is an interstellar traveler, only the third ever detected by humanity. These objects spend billions of years wandering the void between stars before chance carries them briefly into our view. They arrive without warning, pass through once, and then vanish forever. That fleeting presence makes them priceless. To scientists, 3I/Atlas is not a threat or a curiosity. It is a messenger from deep time and distant places, a natural probe of environments we could never otherwise reach. Studying it means holding, for just a moment, a fragment of another solar system in our sights. And that is a far more extraordinary story than any alien invasion headline. No story about 3I/Atlas would be complete without addressing the spaceship theory. From the moment of its discovery, speculation spread like wildfire. And leading that conversation, once again, was Harvard astronomer Avi Loeb, who had already stirred global debate years earlier with his claim that the first interstellar object, Oumuamua, might have been an alien light sail. With 3I/Atlas, Loeb raised similar questions. He pointed out its early brightness, arguing that such luminosity might imply a body too large to be easily explained by natural processes. He also noted an unusual glow in front of the object, not the trailing tail one would expect from a typical comet. And then there was the trajectory. 3I/Atlas would pass remarkably close to Venus, Mars, and Jupiter, an alignment that he described as so improbable, a mere 0.005% chance, that it invited the idea of deliberate maneuvering. These suggestions were quickly amplified by the media. Manhattan-sized spaceship approaching Earth, or even hostile alien technology. On talk shows, podcasts, and YouTube channels, 3I/Atlas transformed overnight into a Rorschach test for humanity's hopes and fears about extraterrestrial life. For some, it was thrilling proof that we were not alone. For others, it was an existential threat. But in science, claims must be weighed against evidence. And here, the evidence told a different story. The brightness was fully accounted for by the coma of dust and gas reflecting sunlight. The so-called glow in front was explained by the comet's rotation and jetting behavior, as dust vented continuously from the sunlit side. And the improbable planetary flybys? While rare, such alignments do occur by chance, especially in a solar system filled with massive planets exerting gravitational influence. The reaction from the scientific community was strong. Oxford astronomer Chris Lintott dismissed the alien craft idea as nonsense on stilts. Others called it a distraction from the genuinely groundbreaking science at hand. Astronomers working on the data emphasized that 3I/Atlas was behaving exactly as a comet should, and that every observation strengthened the natural explanation. Still, Loeb's claims serve as a reminder of the delicate balance between bold speculation and responsible science communication. On one hand, daring ideas can inspire curiosity and public engagement. On the other, when magnified by sensational headlines, they can overshadow the evidence and mislead the public. In the end, the spaceship narrative was just that, a narrative. But its popularity revealed something profound, our collective fascination with the unknown. The thought that a visitor from another star could also be a visitor from another civilization taps into some of humanity's oldest dreams and deepest fears. It is precisely this tension, between imagination and evidence, that makes stories like 3I/Atlas so powerful in the public consciousness. When the first measurements of 3I/Atlas were released, the headlines again took over. Early estimates placed its size at a staggering 20 kilometers wide, about the size of Manhattan. It sounded terrifying, and the world latched onto that image. But as more data poured in, that first figure began to shrink. Using the powerful vision of the Hubble Space Telescope and the brand new Vera C. Rubin Observatory, astronomers refined their calculations. Instead of being 20 kilometers across, 3I/Atlas was likely somewhere between 320 meters and 5.6 kilometers in diameter. That's still enormous, but it placed the object firmly within the known range of large comets. This constant narrowing of the numbers wasn't a mistake. It was the scientific method in action, starting with rough snapshots, then sharpening the picture as better tools and more data arrived. To the public, it felt like scientists were changing the story. But in truth, this is how science works. Each refinement brings us closer to reality. And the reality is extraordinary. Observations revealed that 3I/Atlas isn't just a chunk of rock, it's an active comet. Telescopes detected a glowing coma, the halo of gas and dust released as sunlight vaporized ice on its surface. That coma stretched 24 kilometers across, dwarfing the solid nucleus hidden at its core. Hubble even spotted a faint dust plume and the early signs of a developing tail. Spectroscopic instruments added another layer of proof. They picked up the telltale chemical fingerprints of water ice grains, water vapor, and hydroxide ions within the cloud around the comet. These signals left no doubt. This was not an alien ship or an engineered object. It was a comet, a frozen traveler carrying the raw ingredients of planets. What makes 3I/Atlas unique is its origin. It formed billions of years ago in the protoplanetary disk of some distant star system. Then, through gravitational nudges and cosmic accidents, it was ejected, cast adrift into interstellar space. For eons it wandered, frozen and silent, until sheer chance carried it past our sun. In that sense, it is a time capsule, a sample of chemistry from a world humanity will never visit, delivered to our doorstep by the laws of physics. Compared to the first two interstellar visitors, 1I/Oumuamua and 2I/Borisov, 3I/Atlas is the fastest and most energetic. Hurtling at 210,000 kilometers per hour, it streaks across the sky like a bullet through glass. Its speed alone tells us it has been drifting freely for billions of years, perhaps originating in the Milky Way's thick disk, a region filled with ancient stars and turbulent histories. For scientists, this makes 3I/Atlas not just another comet, but a once-in-a-lifetime opportunity. Every fragment of dust, every molecule of vapor, is a clue to the conditions of alien worlds. By studying it, we are, for the first time, directly sampling the chemistry of another solar system.